Right, so let's review this. So evaluating large language models and evaluating instruction following. The reason why I'm reviewing this paper today is because our work that actually kind of relates to this in a very deep way. In the sense that it's very closely connected to this, right? So like we're focusing a lot on how the language model can follow the instructions that we put into the system prompt. And I think that if we review this paper, it would be a good way to start like looking at it from like a theoretical perspective of like whether we're following the correct things or not, right? So start by reading the abstract over here. So yeah, they introduced like a new meta evaluation benchmark named LLM bar, which they separated out the 419 pairs of outputs, with one adhering to the instructions and other being diverging. So it could possibly be like deceptive qualities that might mislead an LLM evaluation, right? And this kind of sets the framework of like how good the language model would be at following the instructions that put in the system prompt in the user query. So what they essentially like cover here in this paragraph is the fact that the they ask the question of, okay, what's like a good meta evaluation framework, right? And if you wanna like, before we even go on with this, you gotta understand what the meta evaluation is. So the way the meta evaluation is kind of like done is that you're assesses you're assessing the output of the LLM in like meta strategy, right? So the idea is to actually go ahead and see whether the humans agree with like the output of the LLMs, and humans tend to have like innate preferences like such as agreeableness or like, for example, a longer response length, right? So through that, this paper kind of argues that we need to kind of account for those factors when we're trying to evaluate the adherence of the LLM following a system instruction or prompt. So in response to this, they create the meta evaluation benchmark for which is LLM bench, right? And then they go ahead and try to evaluate, and this sets the framework for like seeing, okay, how well does it follow. And now they're starting to explain how like the instruction quality and objective preferences are like enforced. And I think we should go back to the what's it called, the abstract over here, right? The abstract does cover like the end sentence is covering like, okay, like what they're exactly proposing, right? And the beginning kind of gives like a context for the whole situation over here. So they essentially go ahead and like explain like the data structure for the LLM bar. So the I over here would be the input instruction, right? The O1 over here would be the two, well, O1 and O2 would be the two corresponding outputs, right? And P can be one or two, so P is either selected from O1 or O2, and that's the goal preference label objectiving like indicating that, hey, like OP is objectively greater. So in this case, it would be like if O1 is better than O2, O1 is objectively better than O2, and vice versa. So over here, like this essentially, as previously discussed, they split the um, benchmark into two categories or two parts, right? So there's like the natural, and there's also the adversarial collection, right? Or the set. So the natural set basically is like the objective metrics, like hey, like there's two O1 and O2 are two objective answers, and there's no discernible difference in like the subjective qualities differing them, or like there's no like kind of like confusing fact for the LLM, right? It's like saying like, let's say we're comparing cars, right? So if I say Toyota Corolla is the best car and the O2 can be, well, that's O1. If O2 is like Toyota Corolla is the best car due to XYZ reasons, we can objectively state that O2 is the better answer here, right? Because it provides reasoning for like the original assertion that it made. So this is like the exact example that, I mean, this is kind of like the example that we're working off on here. It's like, is that like there's an objective reason why O1 and O2 have like a difference, and like which P selects on. Whereas the adversarial one is like more like, it's more like they both might provide like a similar answer, but the reasoning or like the quality of the output is hidden um within the actual text itself. It's not within like the length of the output or how the output looks, right? Like they're designed to be confusing to the LLM in like a for like a lack of better words. So that's exactly what they're doing for. I'm not gonna focus too much on the natural set. It's You guys can pause the screen and read that. But to further like develop on the adversarial set, right? It's like they first generate like the challenging instances, right? And then they go ahead and the O1 should faithfully follow the instructions of I, right? As you can see from the input, and O2 would be like a superficially better answer, right? But a good evaluator, a good judge should be able to select O1 and discern like the differences between the superficial differences that O2 present to the end user, or just in general, right? Now this is where I see a problem to be, right? Because the well, at least on first sight, like if you're using four ChatGPT based evaluators from Alpaca Form and in two different presentation orders to obtain eight preference labels, right? We- So we filter out the candidate instance if the majority of these preferences are aligned with our expected one. This is followed by manual filtering and modification by authors to ensure objectivity and correctness, as was done for natural. So essentially, what they're saying is that like they go ahead and like have these what's it called? They have O1 and O2, right? And O2 and O1, and they gain eight preference labels, right? So because what they're doing is essentially like getting like, okay, is O1 better than O2? Is O2 better than O1, right? And then in the other order is O2 better than O1 and O1 better than O2. Apply for O1 and O2 and O2 and O1 and you'll get 8. At least that's what I'm thinking, right? And for filtering out the candidate like instance, right? Like so it basically says with among these eight preference labels, if the majority are agreeing with like the expected one, like they say in the test, they're like, okay, O2 is generally better, O1 O1 is generally better. If if the if the consensus doesn't align with this, then they don't accept that um into the data set, right? They and then after this has been processed, they then proceed to do like it manually and modify like the each O1 and O2 instance or the candidate instance in order to like ensure like the objectivity and correctness, right? But it would have also been kind of a bit better to see like uh how do they ensure the objectivity and correctness, like I would prefer to also see like, okay, who are the people that are in charge of doing this? Is it the researchers themselves? Is it like domain level experts? Like what kind of, I mean, that's easily like, it's easily findable if you just look at like the core or base data set, right? So let's go on. Yeah, I'm gonna need some help understanding this actually. So I'll just go to plot and ask them to explain this. Explain this. So you can see that, for example, over here, GP Claude went ahead and said, okay, like this can be P1, right? But if we had clearly, like earlier in our scene, like in the text, we had read that like P is either from a set of one or two, right? So if you were to like read this independently of like the report itself, you would be pretty confused, right? So based on what like Claude is like explaining over here, right? Like so they first find like a neighborhood instruction, right? So what they do is, this is a cousin similarity, and they first find I naught and I, right, using a sentence embedding model, and the, what's it called? I don't even know what this is. It epsilon? I don't even remember, to be honest. It is epsilon, okay. So epsilon is like the threshold to ensure that I naught and I are semantically different enough, right? Now it should be, so I naught is the argument max of the similarity between this thing and this naught, okay? Where I naught is a set of, I don't know, understand math too well. I'm gonna have to read this up, right? So like basically from the first round of Claude, if I'm understanding it correctly, right, they start with the instruction I from the data set, like D, okay, right, and then they find a similar but different instruction data set, I mean I naught, and then they use cousin similarity to find the instructions that are close but not too close, right? So the cousin similarity is actually used for the comparison between I and I naught, and if it's above a certain threshold, then they're considering, okay, like it's going to be fair enough, right? So now you basically have like an adversarial pair, right? So you have the uh you use I and I naught, and you use the weaker model to produce output with I, and then you use a stronger model to produce an output with I naught, right? And based, then you have O1 and O2, right? And you have, so now you have the initial instruction set I, and then you have O1, which was determined from I, right? And you have O2, which was determined from I naught, and you also have P, which is determined from the using I naught, which is because it was a stronger model, right? So O2 might actually look better superficially because you're using a stronger model to produce that, right? But that doesn't actually answer the question of I. It answers I not instead. So what they're essentially setting this benchmark up for in a way is that, like, let's say I have a question of what's the best car, and I have a question of what's the ideal or what's the best small car, right? These would show up to be pretty high in terms of causal similarity, right? Now, when you go ahead and create an answer using the weaker model for what's the best car, and when you go ahead and use a stronger model for creating an answer to what's the best small car, which is I naught in this case, right? It's going to be, if you look at it plausibly, right, like it's going to see that okay, like I naught might be the better answer because it's longer and more detailed, but it doesn't actually address the root question of what's the best car. Like this might not be the best example, but I hope that it makes sense. I'm not gonna break down the math, and I'm not trying to explain the math over here, right? It's just that you need to understand the process of how it's done. So, what immediately stands out to me is that, like, how do you know that this is the right way to do things, right? Because when you have like a vector search or like a vector similar, a causal similarity, right? Like it's a pretty clever way of actually like going ahead and doing it. But what I would have rather done is honestly the much longer way out, which is to actually have an A/B test of surveys, like have like a question and answer output, two output sets, right, which are both handwritten by a human, and then have a query that answers these things, right, and have an A/B set of what's better, select that to be my P, right, and have the LLMs, a small LLM and a big LLM, determine an answer to these things, right, and then let that let the comparison of those answers and questions be the determinant of what's a better evaluator. Like, I don't know, it just doesn't, like, I can see how it works, but I'm not intuitively convinced. Okay, refer to the caption. What do you mean refer to the caption? So if I get it's a better chain of thoughts instead of using self-generated reference. Yeah, this is pretty nice. Honestly, it's a pretty good thing to read. Like, you can definitely like learn a lot of different these things here. So I don't think I need to explain vanilla. They don't they don't label, they don't generate the labels. They just instruct the LLM to first generate like a concise reasoning, and then once it generates this concise reasoning, then it goes ahead and selects like its preference. This is just I don't know, just funny. Intuitive LLMs could benefit from the metrics that you specify what the problem that generates good output. The metrics. Okay. Swipe plus COD. So this would probably be the best way, because you can see, right. Yeah, this definitely, like, the positional bias is like an extremely strong thing that goes ahead. So essentially, swap plus COT is the best framework. So the way that this kind of works is that um let's first cover swap. Do we have swap anywhere? No. So chain of thought is essentially generating, like, first generate concise reasoning and then generate like the preference, right? And then swap is essentially like, where do I find it, right? Swap generated, swap generated reference, right? They don't explain swap. Where's swap? Okay, rules metrics. I don't see swap at all. Maybe because the picture's not loading each prompt. I should probably go to the. It's Amazon. Okay, whatever. Screw it. Let's just read. So, existing for work, blah blah blah. When the position of the two outputs is swapped, the evaluator often generates contradictory preferences inspired by da da da. Let's read this reference over here. What is that? Do at L, improving through multi-agent debate, right? Listen, guys, if you guys want to learn, like, this is the only way to do so, honestly. Right? We first prompt the LLM to give its preference using the chain of thoughts using the orders O1 and O2 and O2 and O1 to kind of account for like the difference in like the contradictory output that the final evaluator might be given. And then we instruct the by synthesizing the two chain of thoughts. So it basically takes the two chain of thoughts like, hey, O1, O2, give me a chain of thought on what your preference is. Hey, O2, O1, give me a chain of thought on what your preference is. Synthesize these two, and so the swapping part is swapping from O1 to O2 and O2 to O1, and synthesizing these two, and we're combining this with the chain of thought. So we tell it to create the chain of thoughts for O1 and O2 as well as O2 and O1, and then we synthesize this using the evaluator to generate what's it called, the to judge the chain of thought, and whatever chain of thought makes more sense is what the evaluator is going to use. So this seems to have the most benefit. I would say, like, in terms of like an overall view, this is honestly not that bad. Like, I've read far worse papers than this. Like, this is honestly a decent paper, right? I've read a lot of worse papers than this, and like, I don't know, like, it's short, it's concise, and like, it gets to the point. Like, I could read a lot of the other stuff, but the video would just go on forever. So I'm just gonna cut the video at this point for now.